Right. Hello, everybody. Welcome to today's edition of Sigstore Office Hours. And yeah, please go ahead and sign in, and you'll see today's agenda. We have one demo from Mark Westerverth. I got that right. And then we have an open session for anyone who has any questions about Sigstore, if you're looking to adopt it or just doing anything with Sigstore in general that you think we can help with. Feel free to ask. And then any other business, any other topics folks have, I've thrown a Hacktoberfest if we have time, talk a little bit about that. So yeah, let's get straight into the demos. So welcome, Mark. Thanks for joining. And yeah, hand over to you.
Well, hello, everybody. Yeah, so I'm Mark. I'm a software engineer at Red Hat on the Emerging Technology Security team. I work with Luke Hines, who's also on the call. Welcome, Luke. And maybe talk a little bit about some of the work that I've been doing recently around connecting supply chain tools, including Sigstore, from end to end. And I will be sharing my screen to talk a little bit more about that. So Sigstore is one of a suite of tools that have been developed for secure supply chain. Among them, another notable one among them is in Toto, which Santiago Torres has been working on. And that, if you're unfamiliar, is basically a tool set that allows you to attest steps in a supply chain and say, this is what happened, and this is how it happened. And there's been a lot of examples of these tools being put together, including Sigstore and others, to kind of put together, a software supply chain, basically showing what happens from source code all the way to compilation and distribution. And that's great, and it's great that we have examples of that, but that's not quite end to end. There's not really necessarily a clear story for what happens at distribution time. Like, how do we know that the code that was compiled by the developer makes it all the way to execution time? And that's where Keyline comes in, which is another project in the realm, but this is kind of focused at the other end of the supply chain. It's a project that provides tools to provide effectively runtime remote attestation, a hardware-backed remote attestation. So if you have a machine running and you have Keyline monitoring that machine, you can verify that the machine state of that machine it matches some expectations that you have. In a nutshell, that's what Keyline is. It has a lot more capabilities, but that's what you need to know for this demo. And the way a user would define what you would expect a machine state to look like is through a Keyline policy. And there are many ways that policy could come to exist, but that's kind of where that's kind of the missing middle. Like, there's no bridge between what happens at the beginning of the supply chain, which is compilation, attestation, uploading to Sigstore, and the end of that supply chain, which is Keyline, and monitoring what happens on the end machine with Keyline. And that's where the thing that I've been working on recently, which is the Keyline supply chain bridge, comes in. And this is basically a tool set that will do exactly what I've kind of been leading up to, which is that it will serve as a bridge between the supply chain that exists at one end, and it will forward provenance information from that supply chain into a Keyline policy that can then be used and remotely attested. So that's what I'm going to be showing off today. The components of this demo, I already talked a little bit about Keyline, which is here. But I also have a simple repository called the supply chain pipeline demo here, which is fairly simple, just has a very basic Go binary called hello Go, just prints hello world, nothing too fancy. But what's important about it is that it also has a GitHub workflow that uses a number of things, including Trail of Bits' excellent Sigstore upload action, which I'm using down here, GitHub action Sigstore Python. And it also uses in Toto. So what this workflow does is it effectively compiles this Go binary and attests that compilation step within Toto, which produces a record of that step and produces artifacts to that effect. It also signs the binary and uploads it to Sigstore, and also tests that. And finally, it'll upload all those artifacts to a GitHub release. And In fact, I will do that live right now. I'm going to cut a new release of this repository, 0.4.4. I'm going to create a new tag, v0.0.4.4, and I am going to say, by the way, is my screen an okay zoom? Do people want me to zoom in? I'm happy to do that. I'll zoom in just in case, but
yeah, looks good to me.
cool. But yeah, so I'm just going to cut a new release, and I'm going to publish this release. And we'll see in actions, we have a new workflow running, and this is going to spin up an action that will install Go, install Python, install in toto, and run exactly the steps that I was mentioning. It'll compile, it'll attest that compilation, and we'll upload the binary to Sigstore. And hopefully this should work. Sometimes this times out and I have to rerun it. Just weird, but yeah, okay, I'm gonna rerun it. Let it finish. Yeah, run jobs. Sorry about that hiccup. That happens sometimes. I think it must be just I get a slow runner sometimes, but usually does not fail like that, seriously. Anyway, that's what will happen. And the end result is that we're going to get a GitHub release that will have a binary. And you'll see the compilation work that time. So we're in business. We're going to get a GitHub release that once this finishes, I go, there we go, finished. If I go back here and go to releases, we'll see that I now have a new release called 0.0.4.4. It has the Hello Go binary. It has the certificate and signature as created by the GitHub Action Sigstore Python action. And it has a few link files, which are the artifacts that are produced from the in toto attestation of compilation. See what that looks like here. I'll download that, open it up, and I'll zoom in. This is what a link file looks like. This is basically attesting that this command, go build, was run and produced this artifact, hello go, with this SHA-256. And it's signed with an identity signature. And that identity signature is actually present in the release as well. So we have a developer key that we can use to attest that this supply chain step actually happened with this identity. So that's kind of a very basic example of what a supply chain might look like. Obviously, it can get a lot more complex, but this is what we need to kind of get started. Was there a question or no? But yeah, so that's just a basic supply chain. Sorry?
I think Trishank has a raised hand. Do you want to ask something?
Yeah, sorry, I don't have the screen. So yes, please.
Oh yeah, no. But I also want to let you finish before heckling you. So.
Oh, okay.
Great.
And in that case, hang on. I think Tyson has a question. He says, "Mark, was developer.pub your public key to validate the .sig?"
No. So this is the public key that attests a developer's identity. So when you would sign with in toto, you use a private key to sign like an individual step. It can verify that in toto step was valid and signed by the identity you expect by using the public key of that private key, if that makes sense. So the certificate and signature here are separate from this developer.pub. So yeah, this is the beginning of a supply chain, as I like to think of it. It's using Sigstore, using in toto, and producing artifacts that will allow us to verify that this binary came from a certain provenance. And now what I'm going to do is I'm going to run the Keyline supply chain bridge, which we'll go over to my terminal here. And I've got a few terminals open here. On the left side, the 3 terminals on the left side is separate VMs. That's Keyline Fedora 1. You can see that here. On the right side, I've got 2 more terminals that are in a second VM, Keyline Fedora 2. For just ease of the demo, I've already downloaded the Hello Go binary to both of these VMs, with the thinking being that maybe, some setup script or a sysadmin would have this binary handy. And they'd have the question, okay, how do I know that this binary has the provenance that I expect from it? And how do I tell that to Keyline? And that's where the Keyline supply chain bridge comes in, which I have cloned here. I'm going to do cd chain bridge. And what I'm going to do is I am going to run the Keyline supply chain bridge. Here it is. Now we've got a few. The Keyline supply chain bridge takes a bunch of inputs. The important ones are you point it towards the GitHub repository. So in this case, I'm pointing it towards the repository I just showed you. I'm the owner, Emba Stavros. The repository is supply chain pipeline demo. And this is just a GitHub token, which is used for using APIs, using the GitHub APIs. I also have a local binary. This is optional. If you don't provide this binary, it'll just go fetch it from the GitHub release. But I happen to have this binary locally, so I'm going to specify the path for that, root hello go. And I'm also going to specify the path where this binary is going to end up on this machine here. And by doing that, that'll allow us to create the keyline policy that I was mentioning. I also have an allow list, which is, like I was mentioning, that's the keyline policy. So that basically describes what is acceptable to be run on this Keyline Fedora 2 machine. That was done beforehand, but it doesn't include any of the provenance information from this hello go binary. And I also am going to use a layout that I created with Intodo, and I'm going to verify that Intodo layout against the Intodo steps that were produced as part of the workflow. And I'm also going to verify against Sigstore. This is an optional flag, but it will basically check against the transparency log and perform an inclusion proof. So that's what we're going to do. I'm going to run this, and there will be a bunch of debug text. It's going to verify the presence. Sorry, it's going to, first of all, it's going to take this binary. It's going to check it against the signature and certificate that were provided on the GitHub release. If those validate, then it will check the certificate and signature against Recore and see if those match. And if it finds a matching entry, then it will perform an inclusion proof. And once that verifies, Sigstore validation will pass. So that's a Sigstore integration. And finally, it will grab all of these artifacts. It will put them in a temporary directory, and then we'll perform an Intodo supply chain layout check. Which will basically say this layout, which is kind of, for those unfamiliar, I didn't really talk about this, but a Intodo supply chain layout is basically what describes how a supply chain should look. And if the supply chain, if the artifacts produced from this supply chain describe a supply chain that matches what you would expect from providing from the provided Intodo layout, then that validation will also pass. Once all these checks pass, we will then have a hash for a binary that we can reasonably expect to be correct and has provenance that has been verified. And then what we do is we take that hash and we just append it to the allow list. And you can actually see we have now keyline policy.json in this directory, which is a valid keyline policy. So what I'm going to do is I'm going to just to show it off what that looks like. Keyline policy, and I'm going to pipe that to JQ. And so that's what keyline policy looks like. And effectively, the part that we're worried about is you'll see file paths, which is the file paths on this machine where the code will be running eventually, and it has hashes. And if the hash doesn't match, then that is a sign that something is wrong, and keyline will tell us. It'll break. You can do other things too, but for now, this is what the demo does. And finally, I'm going to actually run keyline using this new policy. So I'm going to deactivate. I was running in a Python virtual environment to run this tool, but I am going to get rid of that because I am going to use keyline now. So finally, what I'm going to do is I'm going to find in my history here. Now I'm going to run keyline. The keyline tenant is a separate component that will talk to the other components of keyline. So like I said on the left, we have this sort of administrator machine that's running the keylime verifier and keylime registrar in these two terminals down here. And then on the right side, we have a separate machine that's running the keylime agent, which is the part of keylime that actually attests whether machine state is correct and uses a hardware-based TPM to do it. In this case, it wouldn't be using that because this is a VM, but in production environments, it would be using hardware-backed TPM. So yeah, let's add this. We are going to use the allow list that we just created, keylime policy.json. We're going to use a separate excludes list, and we are going to add. When we do this, stuff will begin happening. And you can see now that in this terminal down here, which is the keylime verifier, it is constantly attesting the correct state of what's happening on the right here, which is the machine that we're monitoring. And it seems to be working correctly. It will basically just keep looping like this until something bad happens. And we can see that by running the hello go binary, because it's allowed, because we've forwarded that provenance all the way from the source code all the way down to keylime. We run it, things don't go wrong, which is great. This is exactly what we want. However, if we, let's say, echo some bad additional text to our binary, and we then run it, you will see that keylime breaks. It knows that this hash was not correct, and it will tell us that it is not. And we can then, I don't have this set up, but you can then hook keylime up to take certain actions now that you know that something has gone wrong. But yeah, that's the demo, showing an end-to-end prototype of how supply chains might work and how identity provenance can make its way all the way from source all the way down to runtime. Thank you. Any questions?
Awesome, thanks for that. Trishank, do you want to go ahead?
Yeah, sure. First of all, yeah, agree with Zach and friends. That was a really cool demo. Super sweet. I have a few technical questions. I guess let's go first things first. Do you mind revisiting the link files, the 2 link files?
Sure, yeah. I will share my screen again so we can look at those. It's worth noting that although I produced 2 link files, I only use one of them. So
Gotcha.
Yeah, this is not an entirely complete demo. I'm looking to do a lot of other things with it, but for now, this is what I have. So yeah, so this link is the one that I actually verify. So if we look at the compile link, I'll open it up again and zoom in so people with normal vision can see. Yeah, this is what a link file looks like. This is the artifact that's produced when you attest the compilation step within Toto.
Yep. Have you considered putting the source code of that produced the binary into the materials?
Yes. Yeah, that's probably a next step for sure.
Gotcha.
Yeah.
And is there so let me see if I understand the layout correctly. How many steps are there supposed to be? I'm guessing there should be at least, I'm guessing for right now you're only expecting this one, the compile step. Is that correct?
Yeah. For now, this is still fairly basic. It just verifies this one step. However, the bridge tool accepts any arbitrary layout. So if you have a more complex supply chain, you know, in this case, I didn't have one, but if you had a more complex supply chain, it can validate that supply chain looks correct during verification time.
That's cool. I see. So then you could do interesting things like developers could check in their own link file saying, hey, I committed this source code to GitHub.
Yeah.
So if the compile step doesn't use the source code, something's wrong.
Exactly. Yeah. Yeah. So there's this demo can definitely go deeper and provide strong guarantees, and that's what I hope to be doing. But as a basic demo, this is kind of what's here. Some other stuff that I've been talking to Santiago about this too, and we have some really cool ideas that hopefully will be in the pipeline soon. We might hook up the link files to Sigstore as well. So it could be possible that like we have a hash and we can look against Sigstore to find associated link files and see what that provenance looks like and see if it matches what's provided in the GitHub release, and then we can do even more cool things. So yeah, definitely a lot of potential here for that.
Nice. And I like the idea of using Keyline to use trusted hardware itself to verify that all of these attestations are legit. What about the plan for distributing the layout itself? Is the idea right now that you're going to fix the layout on the client side, or is the idea also to eventually submit it to the store?
Yeah, that's a good question. The assumption with this demo was that the layout would be something that the person running the code would have. That would be something you basically be able to say like, oh, I expect the supply chain to look like this, and then it'll verify that. But that would probably be tedious. You don't want to do that for every single time you deploy Keyline. So yeah, definitely a good question about how that could become more automatable in the future. I think there's definitely some potential. Maybe you could put layouts on Sigstore and have it live there, or as part of the release or something.
Cool. Yeah, no, I mean, this is a very exciting demo. Would love to chat further. Thanks.
Thank you.
I'll echo that. I'll say very, very cool demo. Couple quick questions. So in this demo, just to make sure I'm understanding correctly, the signatures were being done with a key that is checked into the repo, and obviously in practice it would be somewhere, on the proper YubiKey key.
Yeah. So to clarify, the binary signing, so producing the signature and certificate that we saw in the release, that's actually done using keyless. So that's done using like the GitHub ephemeral identity key that's part of GitHub Actions. And
so, sorry,
sorry. There is a key. I did put a key, and I mentioned that was the in-toto identity key. A potential next step is maybe to have that identity key be something we could grab from the ephemeral GitHub Actions environment too. So we wouldn't. It'd actually be like keyless in toto. You wouldn't have to worry about. Including key materials in your repository or as a secret even.
Very cool. I've been paying a little bit of attention over in the Salsa GitHub generators repo. There's been some cool work on having reusable workflows that basically will sign off, and the thing that's missing right now from the keyless part of things is being able to say this artifact was built with this specific action, right? And like the way it's set up right now. I could go in and change your compile sign upload.yaml file to make it do all sorts of things. And so like giving the end verifier a story where they can see like what build process was used.
Yeah, you're getting into a topic that I've talked with Santiago about already, which is potentially augmenting Keyline to accept additional requirements for attestation. So you could say like for a specific binary, I expect it to have a specific level of Salsa attestation, or I expect a transparency proof inclusion. And it could perform those checks on the Keyline verifier. So that's part of that sort of last mile chain of trust. And I think that could be very exciting because that provides even further guarantees, and it's not something that's like a separate tool in the middle. So yeah.
Yeah, super cool. I'll just I'll curtail this for now, and I'd love to talk to you further later. But I'll drop a link in the chat to an issue over on the Salsa GitHub generator, basically about enabling this kind of, because for Salsa 3, it's very important that the keys that you're using to sign are not available to the build step. In some sense, we have this right with your current setup where you have the artifact signed keylessly at the kind of, but
yeah, no, definitely room for improvement in terms of keyless, but yeah. Anything else? Any other questions? Happy to answer. Also, thank you for the links, everybody. They were very helpful. I will be having a look at all of them.
Yeah, that sounds like we don't have any further questions or comments. So yeah, no, thanks very much, Mark. That was really insightful.
Thank you for having me.
Yeah, thanks for yeah, I know you're saying it's kind of rough and ready, but yeah, that was pretty good, and do encourage that certainly inspires us to get thinking about things.
Yeah.
Perfect. Okay, so moving on, next, open it up to any Q&As. This is office hours. We have some folks from the community happy to answer your questions. Does anybody have any questions they'd like to raise around Sigstore adoption or anything Sigstore related, really? Giving a chance anyone who needs to unmute. Okay, yeah, let me know if there is, but in the meantime, I will do a quick plug for Hacktoberfest. I know there's been some chatter in the communication channels, in Slack, and folks are excited to do that. I'm trying to pull together a blog post just to announce like Sigstore's participation in Hacktoberfest. So this is the start of a document. It doesn't have that much in it, but one thing I'd like to get in before we push that live is just talking about the main repos we'll have. So far, it looks like we have cosign, and likely we'll have some doc stuff. We do need to just mark each of those repos as opt-in to Hacktoberfest, and then have a few issues tagged with the Hacktoberfest or Good First Issues label. So just as a plug, if folks are happy to be maintainers or reviewers for issues coming in through Hacktoberfest, do sign up in that doc and do start tagging issues. And yeah, if you are the repo maintainer, if we can help by turning on the opt-in, that will be useful. So yeah, just wanted to flag that here, but we'll continue chatting in Slack. And let me know if anyone has any questions, comments on Hacktoberfest. Yeah, frankly, don't really know where September went to, but October is, yeah, just around the corner. So looking forward to that. Okay, anything else? Last call for comments and stuff. Otherwise, we'll leave it there. The recording will be available for anyone who has any follow-up. And next week, we switch back to the community, Sigstore community meeting. Luke Hines will be running that as I'm away that week. But yeah, we'll see you then or in a couple of weeks. All right, thanks, everybody.
Great, thanks. Bye.
Bye.